Okay, what are the solutions? So this is what we're going to do here. These are a little bit complicated, but it's fine. We need to solve this by saying we're undoing it and to solve for x. So we say if we have -3/4 x minus 8, we need to add 8 to undo that part. Okay, less than 1/2 plus 8. So then we get -3/4 x is less than, this is just 8.5. And now, how do we undo a fractional coefficient? We multiply by the reciprocal. Okay, but what's the reciprocal of -3/4? It is -4/3. And what are we doing here on this step? We are multiplying by a negative number. What happens when we multiply by a negative number? At the exact step that we do that, we flip this sign. Okay? So times -4/3, like that. Okay? This amount right here, the whole point of it is to cancel out just x. So we've got then x is greater than, and this math we have to do over here. Let's do it down here on the bottom. We've got -4/3 times, and this 8.5, if we turn this into an improper fraction, 8 times 2 is 16, plus 1 is 17. That's like 17/2. Okay? And multiplying across, actually let's cancel first. Let's cancel this 2, becomes a 1. This -4 becomes a -2. And now when we multiply across, we get -34/3. Okay? And if we put that 3 into that -34, we can say it goes in negative, let's see, 3 times 11 is 33. There's 1 left over. That is our answer. Okay? And it's telling us to check the solution, so we can plug in, and this is where it gets a little bit tricky to do your proof here, but we'll do it anyway because it's telling us to. -3/4 x minus 8 is less than 1/2. The first proof that we're going to do is we're going to check that as an endpoint. Okay, so we're going to say -3/4 times, and actually, let's keep it as this for a second. Even though, watch, even though this is equal to this, I'm going to keep it in this form right here, just because it makes it a little bit easier to do the calculation. Okay, so we say the number we're plugging in, and I'll write it as -34/3 minus 8 less than 1/2. And what can we cancel? Well, when we're multiplying, we can cancel those 3's right there. Okay, and we can actually cancel the negatives as well, because negative times negative is positive. And we can also cancel this and this by 2. This becomes a 2. This becomes a 17. And then simplifying it out, we've got now 17/2 minus 8 is less than 1/2. And 17/2 minus, well, what is 8? 8 in terms of halves, it's 16/2. 17/2 minus 16/2 is 1/2. Now notice this. This is really interesting. Is this true? Well, no, it's not true, but that's not the point of these types of proofs. The first number that we check is not supposed to make it be true necessarily. It's supposed to give you the same number on both sides. Do we have the same number, the exact same number on both sides? Yes, if we do, then that means this number is the correct number. Okay? And what we now are going to do is we're going to do a second part of this proof to check whether it's pointed in the right direction. So, I'll do it again. I'm going to write the original equation, -3/4 x minus 8 less than 1/2. And now what I'm going to do is I'm going to pick a value that makes this true. Okay? And since x is greater than this amount, I can pick anything greater, and something really easy that's greater than this amount is 0. Right? 0 is greater than a negative number. So if I put that in, I can check and see whether my inequality is pointed in the right direction. So I say negative 3/4 parentheses 0 minus 8 is less than 1/2. And negative 3/4 times 0 is just 0. So 0 minus 8 is negative 8 is less than 1/2. And is this true? Is negative 8 less than 1/2? Yeah, it's true. So I know that my inequality is also pointed in the right direction. That's how you do a proof for these. Okay, you solve it out, you take the value that you got, you do a two-part proof. The first part, you plug it in and say, does it work out the same number on both sides? If so, then this is the correct number that we should have here as an endpoint. And then, by plugging in something that makes this inequality true to the original problem, we can see whether we're pointed in the right direction if it's also true. And it is. So there's one more on. Okay, we're going to do the same thing. This will work out a little bit more nicely than the last one did. That last one was pretty tricky numbers. But first we got to solve it. Okay, we say 4x plus 6. We need to subtract that 6 away. Okay, it's less than negative 6. Subtracting that 6 away. And this becomes then 4x is less than negative 12. Okay, now I need to divide by 4. I need to divide by 4. Question, do I flip the inequality because of this negative? No, I do not. I'm not dividing by a negative. Okay, it's only when you're dividing by or multiplying by a negative number that it flips. And just because there's negative numbers in there doesn't matter. It's what you're dividing by. Are you dividing by a negative? No. So don't flip it. Okay, so this is what we have as our answer. And so when we check it, we are going to do a two-part proof. This is a little bit nicer one to see the two-part proof because it's a little bit less confusing than the last one was. Here's your two-part proof. First thing that you do, you take your original equation. You replace the variable with this exact number that is the end point. Okay? And we get negative 12 plus 6 is less than negative 6. Negative 12 plus 6 is negative 6. Is negative 6 less than negative 6? No, it's not. Does it need to be? No, it doesn't. That's not the point of the first part of this proof. The first part is to check this endpoint and see if this is the correct number. And you know it is if these two numbers work out to be the exact same number when you plug it in. And they do. So whether or not this is true, and it wouldn't be if it doesn't say or equals, it's not the point. The point is to get the same number on both sides. Did you? Great, then this is correct. Now what we need to do is we need to check, is the inequality pointed in the right direction? Okay, so we do another proof. And we say 4x plus 6 is less than negative 6. And now we need to pick any number that makes this true. And since this says x is less than negative 3, we got to pick something less than negative 3. Okay, could be anything. Some people like to just go one less, negative 4. Totally fine. Okay, so let's pick negative 4 just because. It doesn't have to be. It could be any number that's less than that. So 4 parentheses negative 4 plus 6 is less than negative 6. And then 4 times negative 4, negative 16, plus 6 is less than negative 6. Okay, and what's negative 16 plus 6? It is negative 10. And is negative 10 less than negative 6? Yes, it is. So I'm going to put a check mark on both of these parts of this proof because they both did what we needed them to do. The first part, plugging the exact number in, should have worked out to have the same number on both sides, and it did. Okay, and then picking a number that satisfies this solution and putting it in should satisfy the original equation as well, and it does. So we're good.